weak law of large numbers. Here we prove that Chebyshev's inequality leads to weak law of large numbers. For this, let xn is equal to x1, x2 dot up to xn be the sequence of the random variable with expectation of xi is equal to mu I for all n, and bn is equal to variance of x1 plus to xn, which is smaller than infinity. Now from Chebyshev's inequality we have this much. So in place of k sigma we put epsilon, so that k is equal to epsilon by sigma, where epsilon is greater than 0. So here in place of x we place x1 plus up to xn divided by n, and in place of mu we place expectation of x1 up to xn divided by n, and in place of k sigma we place epsilon, which is greater than equal to 1 minus, and the value of k is placed here. After this we get same as it is, and expectation x1 plus expectation x2 plus up to xn, and this sigma goes up here and epsilon here. As this term denotes xn to the power bar, xn bar or mean up to xn, so we can write it as xn minus 1 by n, and expectation of x1 x2 gives mu1 mu2 as stated in the question or here. So after this we also can write it as mu to the power mu dash n, and we know that sigma is given by variance of xi divided by n, and variance of xi means x1 x2 up to xn divided by n. Now we know that variance of x1 x2 dot up to x divided by n gives you 1 by n square here, and the other rest as it is. After this we can substitute the value of bn here, as v variance of x1 x2 dot up to xn is bn. Now since it is given that epsilon is greater than 0 is arbitrary, so we can write as limit n tends to infinity bn divided by n square epsilon square is equal to 0. So for given eta is greater than 0, there exists m which belongs to n natural number.